The development of launch vehicle technology began in the early 1970s in India with the determination to achieve self-reliance in the area of being able to launch all class of satellites in the required orbits. An important milestone towards achieving this goal was the first experimental satellite launch vehicle, SLV-3, developed in 1980, which was capable of placing payload weighing 40 kgs in low Earth orbit. An improved version of this augmented satellite launch vehicle, ASLV, was successfully launched in 1992. ASLV was configured with a mission of orbiting 150 kg class satellites into 400 km circular orbits. ISRO further applied its energies to the advancement of launch vehicle technology, resulting in the creation of its workhorse, the Polar Satellite Launch Vehicle, PSLV. PSLV registered its first successful flight with PSLV-D2 in October 1994. It was later operationalized in 1997 with the launch of PSLV-C1, and in these more than 20 years, ISRO has perfected its regular operational launch capability with PSLV, thereby mastering rocket science. With 34 consecutive successful flights, PSLV has proved itself to be one of the world's most reliable launch vehicles. It has made India self-reliant in launching satellites weighing up to 1,750 kgs into the polar orbit and 1,425 kgs to geosynchronous transfer orbit. PSLV has launched various historic missions like Mars Orbiter Mission, Chandrayaan-1, Space Capsule Recovery Experiment, Indian Regional Navigation Satellite System IRNSS, etc. For the very first time, PSLV-C2, by launching 3 satellites, demonstrated multiple satellite launch capability. Since then, 17 missions of PSLV have launched multiple satellites in a single mission. In 2008, PSLV created a record for most number of satellites placed in orbit in one launch by launching 10 satellites into various low Earth orbits. At the end of June 2016, PSLV C-34, in its 35th consecutive launch, will again make history by launching 20 satellites in a single mission. The vehicle is carrying 4 micro-Earth observation satellites weighing 85 to 130 kgs, each belonging to foreign agencies. M3MSat of Canada will collect and study automatic identification system signals from low Earth orbit. SkySat Gen 2.1 of USA is for Earth imaging. Lapang A3 of Indonesia is for Earth observation, for land use, natural resources and environment monitoring. BIROS of Germany will monitor and study the high-temperature events of the Earth. The rocket is also carrying 15 nanosatellites weighing 4 to 30 kgs each, which includes Canada's Earth observation satellite GHG-SAT-D, 3 quad packs containing 12 Dove satellites from USA, and 2 student satellites, 1 each from Satyabhama University and Pune Engineering College. Overall, the PSLV C-34 mission is launching 17 satellites of foreign agencies, including those from US, Canada, Germany and Indonesia. The PSLV C-34 mission is launching ISRO's latest cartographic satellite, which is 4th in the series of satellites. As a follow-on mission, it will provide high-resolution images in panchromatic and multispectral bands. The satellite carries 4 cameras, which were designed, fabricated, assembled and tested at Space Applications Center, SAC, Ahmedabad, while the optics for the cameras were provided by Laboratory for Electro-Optic Systems, LIOS, Bengaluru. Both the panchromatic and the multispectral cameras provide continuous imaging. Panchromatic camera takes grayscale pictures of the Earth in the visible region of the electromagnetic spectrum. The multispectral camera will provide data for color images using 4 bands of the electromagnetic spectrum. Space Applications Center has developed new technologies in detection systems, camera electronics, including power electronics and miniaturization of mass and volume. The spacecraft has been designed, integrated and tested by ISRO Satellite Center ISAC. The spacecraft's onboard computer, sensor processing, attitude and orbit control and thermal control functions, the power generation, communication systems and many others have been developed in ISAC. Subsystems developed in other ISRO centers like inertial systems from IISU, reaction control systems from LPSC and sensors from LEOS are brought to ISAC, where they are assembled and integrated into the spacecraft. The solar cells mounted on the solar panels generate the necessary power for the spacecraft. Lithium-ion batteries store the generated energy to support the spacecraft during payload operations and eclipse. The antenna systems of the spacecraft will transmit the recorded payload data from the spacecraft to ground stations. The data from the satellite will meet the increasing user demands for cartographic applications at village, town, or sub-meter level for the development of various urban and rural resource management, coastal land use and regulation, utilities mapping, LIS, GIS, and disaster monitoring applications. Till now, PSLV has successfully orbited 33 Indian and 57 foreign satellites belonging to agencies of 21 countries. PSLV, with its capability of launching multiple satellites and in different orbits, is truly ISRO's most versatile launch vehicle.